guys. So we talked about how sometimes we might need to do a substitution that will result in a partial fractions. And we said that there are two main times that happens. One, when you just have like something show up all over the place in the integral, and so you want to get rid of it to make the integral look more familiar. The other is this type of question right here, where we have this radical involved. We have that square root, and we do the type of reverse substitution that we've seen, where we let our u equal to the whole square root. So in this case, we've said we can let u equal to just the thing under the square root or the whole square root. And this particular problem, if I just let u equal the thing under the square root, that 2x plus 4, the result will still require me to do another substitution where I get rid of that square root. So I urge you to try that on your own and see what happens. I'm actually just going to straight up let u equal to the square root. So we're going to let u equal to the square root of 2x plus 4. And then this is a type of rationalizing substitution. When we let u equal to a square root, the first thing that we do is get rid of that square root. Then I'm going to take the derivative of both sides. So 2u du is equal to 2 dx. And now this thing happened where I have a 2 on both sides. I can actually cancel out those 2's like that. So I'll have u du is equal to dx. So that dx right there is just getting replaced with u du. Now, note that I also have an x right there, so I'm going to need to solve for x, do my reverse substitution, so that I can replace everything in the integral. This x is there, so what does x equal? Well, 2x is u squared minus 4, so x is equal to 1/2 times u squared minus 4. Now we have everything necessary to replace everything in the integral. I'm going to move that constant to the outside. My dx was u du, so I'm just going to put a u up there. X is 1/2 times u squared minus 4. The square root of 2x plus 4 is u, and then we have du here. So first of all, those u's actually cancel out. Goodbye. It's all multiplication, so I can cancel things out. Second, that 1/2 in the denominator. Remember, division by a fraction is the same thing as multiplication by the reciprocal. So this is like multiplying by 2. And this gives me 1 over u squared minus 4 du. Now this is not a known form. I can't just look at that and write down the answer. It is, however, a rational function. I've got a polynomial over a polynomial there. The derivative of the bottom does not equal to the top, so substitution is not the best way to go. So we're going to start with partial fractions. And the first step is to check whether or not we need to divide. Well, the numerator is just a constant, so the degree is 0, and the degree of the bottom is 2. It's a quadratic polynomial. So the top is less than the bottom, so no division is necessary. And then my second step is to factor the denominator. So u squared minus 4 is equal to u minus 2 times u plus 2. That's just a difference of squares that we have there. So then for my third step, we're going to create our partial fractions decomposition. So I can have 1 over u minus 2 times u plus 2 is equal to a over u minus 2 plus b over u plus 2. And for step 4, when we want to solve for those numerators, I'm just multiplying by u minus 2 times u plus 2. Before we do that, though, I just want to point out that this was actually a case 1 problem because u minus 2 and u plus 2 each only occurred 1 time. This was a product of distinct linear factors. None of them occurred more than 1 time. So they each occurred 1 time. They each only got 1 fraction. So now I'm multiplying both sides by u minus 2 times u plus 2 to get 1 is equal to a times u plus 2 plus b times u minus 2. And that is my first step of solving for the numerators. So then for b, we want to plug in u values starting with the zeros of the denominator. So here are my zeros. Our u is equal to 2 and negative 2. Remember, those are just the values where the denominator equals to 0. So we'll start by plugging in negative 2 And I get that 1 is equal to a times 0 plus b times -4. So b is equal to -1/4, and u is equal to +2. I get 1 is equal to a times 4 plus b times 0, and a is equal to 1/4. So I solved for a and b. Because this was case 1 and not case 2, I didn't have to plug in a u value that was not a 0. I was able to solve for both of my numerators using only the zeros of the denominator. We saw in case 2 that sometimes we might have to plug in another u value of our choice. Not in this case. All right, so this brings us to step 5, which is to rewrite the integral. Now remember, when our numerators are fractional, we still just want to leave them in the top. So in other words, I have this is equal to 4, there we go, 4 times the integral. A is a fourth. I'm not going to bring that 4 down to the bottom. I'm going to write the fourth up on top, u minus 2. Plus b, which is -1/4, u plus 2 du. And now this just makes my life easier in terms of solving, not having that 4 down there on the bottom. That can get confusing. But I also want to point out that this 4 out here, if I distribute it back inside, it actually just gets rid of those constants entirely. They just become 1. So this is actually 1 over u minus 2 minus 1 over u plus 2 du. And because this was case 1, we didn't have any of those cases where the degree was 2 or 3 and we had to think about how to deal with that. These are just our known form. These are both just a natural log. So this is equal to natural log of u minus 2 minus natural log of u plus 2 plus c. And I remind you, u was root 2x plus 4. So this is equal to ln of root 2x plus 4 minus 2 minus ln of root 2x plus 4 plus 2 plus c, and that is my final answer here. That's all for this problem.